Hello everyone. In this video we are going to be talking about the determinants of a matrix. This is a continuation of the series of problems we've been working on matrices. To see one of them, just click on the link at the top right hand corner of the screen. We are going to begin with a 2 by 2 matrix. Consider this matrix A equals A11, A12, A21, and A22. This is a 2 by 2 matrix because it has 2 rows and 2 columns. The determinant of A, it can be written as det A or uppercase A enclosed within 2 straight lines. It's going to be equal to A11 times A22 minus A12 times A21. So basically, this is how we work out the determinants of a 2 by 2 matrix. We would need to identify the elements on the leading diagonal. That's the diagonal that runs from left to right. So here there are 2 elements here, A11, A22. Multiply both of them, then minus the product of the elements on the other diagonal. That's A12, A21. So this is how to compute the determinants of a 2 by 2 matrix. Let's take a quick example. For example, if we have a matrix W having these elements 0, -2, 1, 3. So the determinant of W is just going to be 0 times 3 minus -2 times 1. So this is going to be equal to 0 times 3 is 0 minus -2 times 1 is -2. So this is, so negative is positive. So we have the determinants of W as positive 2. Okay, so how about the determinants of a 3 by 3 matrix? Let's consider this 3 by 3 matrix. To obtain the determinant of this matrix, the first thing we are going to do is to break this matrix down into the determinants of 2 by 2 matrices. To do that, we are going to put a sign, positive, negative, positive, in this order on each column of the matrix. Now, there are a number of ways of doing this, but my choice is going to be to select row 1. So the determinant of B would be the positive, then the elements in the first row and first column, that's B11. The next thing is going to be to close the first row and the first column, and I'm going to be left with B22, B23, B32, B33. So what I just did was, since I have a B11 outside, and B11 is the element in the first row and first column, so I closed the first row and first column, and I'm left with these 4 elements. So that's how I ended up with this. Then the next one, I've got B12. It has a negative, so this is negative B12. I'm going to do a similar thing. Close all of the elements on B12 row and B12 column. So here is it. I'm closing these and these. Thus, I'm left with B21, B23, B31, and B33. And finally, the third one is B13. The sign on it is a positive, so this is B13. I'm going to do the same. Close all of the elements on the same row as B13 and all of the elements on the same column as B13. If I do that, I'm going to be left with B21, B22, B31, and B32. Thus, I've got a B11 here. Now the determinant of this matrix, this is a 2 by 2 matrix, so we are just going to follow this approach. So this is B22 times B33 minus B23 times B32 then the next one is B12, negative B12, I beg your pardon. Then the determinant of this matrix, that's going to be B21 times B33, then a minus B23 times B31. Then finally, B13, then the determinant of this matrix, B21, B32, minus B22, B31. So we can just remove the brackets here and we'll get the determinants of B. So this is the determinants of matrix B. Find the determinant of C if C equals 0, 1, 2, 3, 4, 5, 6, 7, and 8. So solution. The first thing we are going to do here is to have these signs, plus, minus, plus. Now as usual, we are going to focus on the first row. The first element here is 0. It has a plus 0, so the determinant here is going to be plus 0. Then we would close, 0 is in the first row and the first column. So we would close the first row and first column and be left with 4, 5, 7, 8. Then negative 1, that's the second one. Negative 1 is in the first row, second column. So we are going to close the first row, second column, and would have 3, 5, 6, 8. Then the next one is positive 2. Positive 2 is in the first row, third column. So we are going to close first row, third column, and be left with 3, 4, 6, 7. So this is going to give plus 0, that's 0. Then the determinant here is going to be 4 times 8 minus 5 times 7. Then minus 1. 3 times 8 minus 5 times 6. Then plus 2. The determinant of this matrix, 3 times 7 minus 4 times 6. So this is equal to 0 brackets. 4 times 8 is 32. 5 times 7 is 35. Then negative 1. 3 times 8 is 24. 5 times 6, that's 30. Then positive 2. 3 times 7 is 21. 4 times 6 is 24. So this gives 0. 32 minus 35 is a negative 3. 24 minus 30 is a negative 6. Then positive 2. 21 minus 24 is a negative 3. So we've got 0 times negative 3, that's 0. Negative 1 times negative 6 is positive 6. 2 times negative 3 is negative 6. So we can see that the determinant of this matrix C, 0 plus 6 minus 6, and that's 0. So this is how to obtain the determinants of a 2 by 2 and a 3 by 3 matrix. In our next video, we are going to be exploring another method of obtaining a 3 by 3 matrix called the Saros rule. It's a very important and interesting approach to solving the determinants of 3 by 3 matrix, and I think it's kind of like shorter and way easier. See you then. If you find this video useful, kindly like, share, drop a comment, and do not forget to subscribe. Thank you for watching. See you in the next video.